So we've talked about this structure that we use for creating a class that starts with our fields, followed by our constructors, followed by our getters and setters. We can also write any other methods that we might need here. Let's do another one. We'll make a method called bark. And we need a return type. I'll make it a string. And we'll return. We need to return a string, so let's return right. So this is kind of the standard. Fields, constructors, getters and setters, any other methods we need to write. And lastly, we want to do one more method that's kind of standard. When we create a class, we should probably always do it. And I want to show you, first I want to show you over here to our dog. And instead of printing out names and age, let's just do let's print dog 1. All right. Not going to do call any methods on dog 1. So I'm not going to say dot get age, or I'm not going to say dot get name. I'm just going to say the name of the object, dog 1. That's our reference variable. We're just going to print it out, see what happens. And when we do that, we see that it prints dog at 5CA881B5. That's a hexadecimal address of the location in memory where this dog is actually held. Remember, dog is a pointer. It's a variable that points to the location in memory where this object that we created exists. It's a reference. And to go a little bit further, there's different kinds of memory used, and objects are held in a place called heap memory. So when we create this new dog, it creates a new dog in heap memory. But we also create this variable that holds an integer. That's a hexadecimal number, but it's still an integer, that points to that location in memory. And this reference, this dog1 variable, is actually kept in stack memory. All of our local variables, any primitives we create, they are all created in stack memory. And in this case, so dog1, the variable, is created in stack memory, and it holds this value that points to the memory location for our dog object, which is kept in heap memory. So we have stack memory and heap memory. Objects go on heap. Basically, most other things go in the stack. All right, why am I talking about that? What happened here? When I printed dog1, I am going to print dog1 dot toString. I'm going to call a method called toString on dog1. Well, you might say, in our dog class, we didn't create a toString method. But yet there it is. I don't have an error. I'm going to print it out. And it prints the exact same thing as it did a minute ago. It still printed the memory address. So when I print dog1, if I just use the variable, it's automatically running that toString method. Well, where does that come from? If we didn't write it, where did the toString come from? All objects in Java inherit from a class called object. So there is an object class in Java, and every object we ever create inherits from this class. And if you look there is a method called Tostring that is built into the object class. So we've talked about this idea of inheritance in programming before. We've used it a lot in some of our game programming. What does the Tostring do? It returns a string representation of the object. In general, the Tostring method returns a string that textually represents this object. It should be concise but informative representation that is easy for a person to read. It is recommended that all subclasses override this method. The Tostring method for an object returns the string consisting of the name of the class of which the object is an instance, followed by the @ sign, and an unsigned hexadecimal representation for the hash code of the object. This method returns a string of the hash code of the object. So it says we should override it. This behavior isn't that useful to us. Every time we write a class, we should override this method. What does override mean? It means we write a new version of Tostring to replace the one that's built in. So we should always, when we create a class, override the Tostring method. Okay, so let's do this. Public string Tostring. Let's go to our dog class, and at the end, we will write public string Tostring. Now, Tostring exists in our object class. I'll talk about the annotation in a second. Tostring exists in the object class and we inherited it, but now we're overriding it to do something else. What do we want it to do? Let's, in this case, have it return information about that's more useful to our user about our class. Return the dog's name is plus get name. Actually, let's just use the field. And then we'll print dot for the end of that sentence, and the dog concatenate on age, and we'll concatenate onto that a period, so it's a nice sentence. What did I do wrong? Let's put that in print. Helps us. Nope. Oh, there it is. Put my concatenation symbol inside. There we go. So we're going to return a string that says the dog's name is name and the dog's age is age. Save that. Go over here. Now when I print dog1, what happens? Now instead of printing out that hash code, instead we get the dog's name is Fido, the dog's age is 3. That's way more useful to our users. And they don't have to print dog1.toString. They can just, hey, print out dog1. So the Tostring method is almost always going to print out a string, most likely with most of your fields included in it. So if I have 5 fields here, I may want to include all 5 fields. It just makes it user friendly. So just to review, our fields come first, followed by our constructors. We can overload our constructors if we want to. So this is overloading. And remember, overloading is determined when we create the dog. We specify parameters, and that determines which constructor will run. Followed by getters and setters for all of our fields. By the way, if we want a field that people can't change, we can remove its setter. And now, when they create the dog, they can set its name. But if I don't have this setter here, they can never change the name. That's kind of interesting. So, constructors, getters, and setters, any other methods we might want to write, and always override the toString. One other thing on this override for the toString, remember this is override. Back here on the constructors, it was overload. Your browser or your IDE now will tell you to add an @override annotation. You want to do that. Let's go ahead and do it. And all it did is up above, it put an annotation with an @ sign and override. This helps us see that it's an overridden method. But also, it will help us if we're intending to override toString and we don't actually do it, our IDE is going to catch that for us. So what if I put toString with a lowercase s? Now look what this @override did for me. I created a method called toString, but I didn't actually override the toString method because the toString method in Java has a capital S. Okay? And it gives us a little warning here. It says this method does not override a method from a supertype. Okay? So @override doesn't change how our code functions, but the idea that we intended to override, it helps us detect that we didn't actually override. So it's a good idea when you're overriding to put this annotation right above the method that's supposed to be overriding. So this is our standard class. We always write them the same way. Fields, followed by constructors, followed by getters and setters, followed by any other methods that we need to write, and lastly, the toString method. This is by convention, how they should be. In the next video, I'm going to show you some shortcuts.